Hello, good morning, my beloved students. I hope you are all doing well. We are still dealing with circles. We're continuing the same chapter, that is chapter 15, about angles and inscribed quadrilaterals. That's the new topic for today. Now, let's start by solving the homework of yesterday first. We've given this circle that is centered at C. We've given the length of this arc here, that is 60, and the measure of this arc here LM is 70. Now the question is to find angle measures. The first angle is MNP. The second one is LMN, which is this angle here. So starting from the angle MNP, we can directly see that this segment MP, okay, is passing through the center of my circle, and we said from the inscribed angle of the diameter theorem that the inscribed angle in this case is 90 degrees. Great. Now let's move to the second one, which is the angle LMN. So look at this angle carefully. I can divide it into two angles. It is equal to the angle LMP, this one, plus PMN. If I have these two measures and I added them, I will get the measure of LMN, right? So let's start from the angle PMN. What is the measure of this angle? It is half of this intercepted arc here, which is PN. Look, my angle, inscribed angle, its intercepted arc is this, so the measure of this angle is 60 divided by 2, so PMN is 30 degrees. All right? Now, what about the angle LMP? Look what I'm going to do. This angle is 90 degrees. I can say it directly. Why? Again, from the inscribed angle of the diameter theorem, I have MP, this segment, is a diameter for my circle, meaning it's passing through my center. So the inscribed angle should be 90. So the angle at L is 90. Now look at this triangle here. I'm talking about PLM triangle. What is the sum of the angles of a triangle? It's 180. So I have the total is 180 minus 90 minus the angle LPM gives me the measure of the angle LMP. Now, what is the measure of LPM? It is half of the intercepted arc, so 70 divided by 2, which is 35. So this is 35, this is 90, and the total with this is 180. So what is this? This is 180 minus 90 minus 35, which is 55. So the angle LMP is 55. Finally, the angle LMN, this total one, is LMP plus PMN. LMP is found to be 55 and PMN we found it 30. So 55 plus 30 is 85. My angle LMN is 85 degrees. Again, you may find other ways to solve the same question, but make sure you got the right answer as this one. Great. Now let's move to the class of today. There are some relationships that relate the angles of quadrilaterals. Now remember, the quadrilateral is that shape with four sides or four vertices. We are going to speak about the quadrilaterals that are inside the circles, or we say inscribed quadrilaterals. Now, if I look at these measures, in fact, if you have the measurement tool for the angles, you can measure them and check that. Look, A is 95 degrees, B here is 60 degrees, D is 120, and C is 85. Now, look, if I'm adding opposite angles, let's talk about the angle A and C, I get that their total is 180. Now, if I add B and D, their total is 180 degrees. Now, what about the other sums like D and E? Let's check D and E and A. It is 120 plus 95. All right. It is not something special. It's not 180 or 360. Also, if I add, for example, A and B, 95 plus 60 gives me 155. All right. What can you see about these values here? You see that if you are adding opposite angles, their sum is always 180. But there is no specification of adding consecutive angles. So consecutive angles differ. Look, 155, sometimes 145, 205, 215. So there is no special rule for that. So our rule or theorem for the inscribed quadrilateral, we say that if we have an inscribed quadrilateral in a circle, then its opposite angles are always supplementary. You remember that supplementary is 180. Meaning what? Meaning if you have any type of quadrilateral inscribed in a circle, then the opposite angles A and C will add to 180. And D and B will add also to 180. But there is no special rule or theorem telling something about the measurements of consecutive angles, meaning A and D, or D and C, or C and B, or B and A. So remember, this rule is only for opposite angles only, pairs. Now, we wanted to use the theorems that we have seen so far about inscribed angles and arcs to prove this theorem. How can I prove that A and C are supplementary, B and D are also supplementary? Now, look, first I will divide my circle into two arcs. Here I have an inscribed quadrilateral, of course. Now, I will divide into two arcs. I have an arc which is BCD, this green one, BCD. The second arc is DAB. What do you see? If I union them or I add their measures, it will be 360 because they make a full circle, right? So the measure of BCD plus the measure of DAB gives me 360 degrees. Now, look at the angle A. It is an inscribed angle and its intercepted arc is BCD. Look at this angle here. What is its intercepted arc? It is BCD. Now, for the angle C, what is its intercepted arc? It is DAB. Now, we know that the measure of the inscribed angle equals to half of the measure of the intercepted arc, right? So the measure of the angle A equals 1/2 the measure of BCD. Also, the arc DAB is an intercepted arc for the angle C, so the measure of the angle C is 1/2 the measure of the arc DAB. Now, if I add the angle A and C, let's add them together. The measure of angle A plus the measure of angle C equals to half of BCD plus half of DAB. All right? Now, factorize half out. So I have this one is equal to 1/2 the measure of the arc BCD plus the measure of the arc DAB. Now, what is this sum? You remember we said that they make 360 degrees. So this sum here is 360 degrees. Multiplied by half, this is 180. So the measure of A plus the measure of C is 180 degrees. So this means what? That A and C are supplementary. All right. Now you can use the same proof to prove that B and D are supplementary. How are you going to do that? By using the intercepted arcs, the same thing. So for D, what is the intercepted arc? It is ABC. For the angle B, the intercepted arc is ADC. And you go through this. Their sum is 360. You substitute, and you'll find exactly the same. So we've proven that if I have any quadrilateral inside a circle, then its opposite angles are supplementary. Great. Let's take this example. Find the angle measures of each inscribed quadrilateral. I have here a quadrilateral. The angle Q measures to y squared plus 53. The angle R measures to 15y plus 17. All right. And the angle P measures to 5y plus 3 degrees. The question asks to find the measure of each angle here. So we're going to use our theorem. We say that the measure of P plus the measure of R equals to 180 because PQRS is inscribed in a circle. Then we substitute the expressions. The measure of P is 5y plus 3. The measure of R is 15y plus 17. The sum of them is 180. I simplify my equation. So I have one equation with one unknown, which is y. So you take 20 to the other side, and you divide by 20, and y is 8. Now I'm not done. I just found the value of y. Now I need to substitute to find the angle measures. Now for the angle P, it is 5y plus 3. What is y? It's 8, so it's 5 times 8 plus 3, which is 43 degrees. The measure of R, again, substitution, it gives us 137 degrees. The measure of Q is y squared, which is 8 squared plus 53 equals 117 degrees. Now what about S? How can I find it? I don't have any expression related to y here, but I know from the theorem of inscribed quadrilateral that S is supplementary with Q. So Q plus S is 180. The measure of S plus the measure of Q is 180. I know the measure of Q, which is 117. So the measure of S is 118 minus 117, which is 63 degrees. So P is 43, R is 137, Q is 117, and S is 63 degrees. All right. Thank you so much, guys, for today's class. I'll see you in the next session. We will have few activities on today's theorem. Take care of yourself. Thank you.